Greetings everyone. I'm Chinmay Jain, the presenting author of the paper Automation and Monitoring Using IoT in Pisciculture. The co-authors of this paper are Dr. Subradev Das, Dr. Subrajit Singh Roy, Mr. Shippreet Padi, Ms. Madhusni Panda, and Mr. Manas Prabhu. A simple life has been the purpose of humankind throughout history, and automation makes life simple. The Internet of Things (IoT) is the latest introduction into the world of automation, which has helped in automating almost everything. No industry has hesitated in changing its method from manual labor to precise machines, modeled using machine learning and AI developed by skilled data scientists. The fish farming industry is not so different. The paper will introduce how fish farms enter the realm of IoT and make life simple for a person sitting in a remote location, controlling every corner of a huge farm spread across acres of area. The slide shows the outline of a paper, introduction of the problem at hand, methods to handle these problems, the block diagrams, which gives us the visual representation of the methods proposed, analysis, and conclusion. Introduction. A fishing pond's operation depends on a variety of factors, including controlling the water temperature, aeration, fish food, and other factors. The health of the fish might be affected by the water quality. The amount of dissolved oxygen depends on the temperature. The productivity of the fish farms is also affected by pH, aeration, and turbidity. Therefore, more energy and cost effective technologies will tremendously help fish farmers in order to satisfy the rising demands of the constantly increasing population. Fish farms and their daily operations can be more automated with the help of IoT devices and technology. By doing so, fish farmers can get a number of advantages, including increased output. The methods to handle these problems are aeration. The pond will have an Atlas Scientific ENV40 sensor installed to the gauge of water dissolved oxygen content. The measured amount will be transmitted to an application where the pond owner can see it. Turbidity. The amount of eggs that females lay in water when they are spawning is influenced by turbidity. A turbidity sensor with an accuracy of zero point 0.1 NTU is a feature of Manta 40 probe. It operates in a range of 0 to 2500 NTU. pH. It's crucial to keep the pH between 6 and 8 for the healthy growth of fish. A pH sensor kit can be used to check the purity of the water. It can be used in aquariums and water tanks. Temperature. Fishes need an optimal temperature to survive and grow at the fastest rate possible. To keep the track of the pond's water temperature, a temperature sensor DS18B20 is positioned at the bottom of the pond. Identification and monitoring. The use of such technologies in aquaculture is expanding quickly with the advent of the new technological cameras and machine vision. Fish population monitoring and identification are both done using photo or video surveillance. Human specialists use photographs of fish to identify the species. The block diagrams gives us the visual representation of these proposed methods. This block diagram depicts the functioning of a sensor. The parameter taken as an example is temperature, and all of the other sensors work the same way. First, the pond water temperature is measured by the sensor. The data is then collected and sent to the cloud for storage and analysis. If the temperature recorded is optimum, no further action will be needed. However, if the temperature recorded differs from the optimum range, certain processes are used to change the temperature for perfect functioning of the farm. Similarly, all other sensors give the outputs and accordingly the farm runs without human intervention. Another block diagram shows how to establish human control over the farm. No matter how accurate and efficient our system is, there will always be a need for human intervention so that problems can be analyzed and administered without hassle. First, the data stored in the cloud from sensors is run through a gateway. This data is then analyzed by an ML mode 1 designed to diagnose a triple doubleshoot problems. Final report and the summary is then presented to the administrator via a user interface. Then the administration can resolve the problems, if any, for the smooth and efficient functioning of the farm. After carefully analyzing these methods, the results are as follows. This graph shows the dissolved oxygen level as measured once in every hour using F- aforementioned sensor. To reach the optimal dissolved oxygen levels, the pump is adjusted accordingly. This graph displays the turbidity sensor data that was gathered in intervals of an hour. The diagram clearly shows how the turbidity of the pond is controlled to maintain a value of less than 25 NTU at all times. The pH level values collected by the sensor are displayed on this graph. It is evident from the graph that when the pH falls below 6.5, its value is made to increase. When the pH rises over 9, its value is made to decrease. The temperature sensor measurements are displayed in this graph. Every 30 minutes, the temperature is recorded. The concerned devices maintain the pond's temperature between 75 degrees Fahrenheit and 80 degrees Fahrenheit, forcing the graph's maximum points to fall within the given range. Conclusion: this paper proposes an IoT based fish farm with a focus on efficient use of resources, manpower, and capital. Accuracy is improved with the specified sensors. Most of the important parameters were considered in this study: aeration, turbidity, hydrogen potential, temperature control, and fish identification and monitoring. Appropriate and optimal parameters are also specified to operate at maximum capacity without losing resources. This white paper also serves as a gateway to deploy machine learning and AI, using enough data and different concepts such as tensors, neural networks, deep learning, etc., and integrating with Python, C++, and MATLAB capabilities that provide the best parameters for the predicted data. Using language like Arduino and C++, farms can be fully automated without the need for a large staff range. However, there still remains the issue of collecting, cleaning, and processing 4,484 data that should be accurate in order to predict further evolution of the parameters.